safe and clean microdata. I'm Christina Magder. I work for the UK Data Service. I am based at the UK Data Archive at University of Essex. And in my role, I manage the data collections development team and also the research data management team. So what I mainly do is I ensure that UK Data Service is actually appraising and negotiating the correct data within the remit, but I also lead on research data management training and the research data management training portfolio. For about 4 years now, time passes rather fast. I have been training on different types of tools for quality assessment, but also for disclosure control. I'm very interested in disclosure control, particularly because, as we know, especially with changes in legislation, there is even a further need to take into consideration anonymization for the data that we want to share. An icebreaker poll, really fast. If you'd like to go to Menti, the voting code is 64545885. Just to get, I realize it's Monday, people might be a bit like, oh, it's very early for us. So just a quick icebreaker poll. If you go onto Menti, the voting code is 64545885. And smartphones have changed our lives. Anything else, in your opinion, was the best tech invention? I'm not looking for people saying QAMyData, just the best tech invention. Online streaming, exactly, and we've actually seen with online streaming, our usual UK Data Service training that we provide, we've started streaming that via YouTube, and we get even more attendees than usual. ARN vaccine, of course. We're getting a couple in. It's only Monday morning, and I'm here pestering you with this question just to get the rounds going up. Okay, and now let's see, what do you expect to get out of this training? Just a couple of words. What are you most looking forward from this training? It's the same Menti, the same code, 64545885. Better understanding of SDC Micro. Yes, we'll see. I've actually prepared a draft PDF as well, so that you can follow it at your pace as well, because I know I'm trying to put a lot into just a couple of hours. Best practices for data sharing. Yes, we're touching on that, and we're going to learn more about the Data Management Expert Guide from CESSDA, which is a fantastic resource. Info about tools. Yes, we're going to do demonstrations and how to introduce them to colleagues. How to use SDC software. Yes, I'm actually giving a couple of choices. My preferred one is SDC Micro, and I'll go over why, but it is totally up to you. Advice on transcript assessment. This specific session is about numeric data, so it doesn't focus on qual data. However, especially the beginning presentation, because we're talking about Data Management Expert Guide that was created by CESSDA, that actually contains information about transcripts and how to assess them. Understanding on how to train colleagues and students for data sharing. this is what's going to be covered today. Thank you ever so much for completing the poll. We are going to share a lot of information. All of you probably know what CESSDA is, but those of you that don't, CESSDA is the Consortium of European Archives, and the vision of CESSDA is that access to social science data and metadata is vital for both the science and the society, and that we need to offer services, training, for example, to producer in order to easily describe and store their data, and also provision a secure environment when needed. CESSDA is really keen on adhering to the FAIR principle, the findable, accessible, interoperable, and reusable. So the FAIR principles are a basis of data sharing. They set specific standards on how to share best data. And again, we'll go a bit more into detail later on about this. The mission of CESSDA is to provide this distributed and sustainable research infrastructure that enables us in the research community to not only conduct high-quality research, but to actually contribute to the effective solution to major challenges that are facing today. And also, as today, the training today is actually facilitated by CESSDA. We do facilitate different types of training. I have seen in the registration form, some of you would like to be subscribers to the CESSDA newsletter, and I'm going in the follow-up email to include the link how to subscribe to the CESSDA newsletter. CESSDA actually provides a lot of different tools and services. We have the data catalog, the data management expert guide, which I've mentioned just briefly before, the vocabulary service, the ELSE thesaurus as well for keywords and how do we index our data, and CESSDA training. Oh, I do apologize. We're admitting a couple of more people. Welcome everyone that I've admitted. I do apologize. I know it's quite an early start, but I said better finish before lunch and start earlier in the morning. The CESSDA Data Catalog is a fantastic resource for both data provider and data users, because all service providers do have their own data catalogs, but they also have their own designated user communities and their own, I would say, specific users that go to the catalog. However, the CESSDA Data Catalog brings together all the service providers into one catalog. For example, a user that's interested in doing research about COVID-19, because of course we know that a lot of people are actually conducting research into COVID-19 now. Rather than visiting all the different catalogs from the service providers, they can just go onto the CESSDA Data Catalog, type in COVID-19, and actually see what COVID-19 data is available from all the different service providers. CESSDA training, again, it's aimed for data producers, data users, data professionals. And if you haven't checked the CESSDA webpage, I do recommend doing so. There are a lot of trainings upcoming. And as I was just telling you about the COVID-19, searching COVID-19 data, there is actually a roadshow on the 2nd of September presenting what you can find in the CESSDA catalog about COVID-19 data. And there's a nice panel going on as well. So if you have time, please do attend that training session. Now, the CESSDA Data Management Expert Guide, and I've put the link, I've tried to do all the presentations as linkable as possible, so you can use this in your own training sessions or for your own use. The expert guide was created by a lot of different service provider experts in their areas, and it's aiming to make researchers better understand how to make their data fair. It does follow all the chapters in the data lifecycle, from planning to organizing and documenting to processing data to storing and protecting, archiving and publishing, and finally, but not lastly, discovering the data. Because again, what's the use of having this fantastic data that no one can discover? The Data Management Expert Guide is available via Zenodo on a CC BY open license, so please do reuse it in your trainings, point people to them. It's a very comprehensive resource. Today's program, I've mentioned briefly before, is going to be a mixture of presentation and exercises. We are taking 2 breaks. We need to ensure that we're stretching our backs and our legs. But of course, the break is an option to ask questions as well. You can always just message me privately if you'd like via Zoom, or I'm providing my email address as well. If you have any follow-up questions, you can always drop me an email. We'll see that we go into how do you teach on data quality assessment and disclosure control. And the way I've done the presentations is to ensure that you're covering all the main aspects in this, and that you are touching on the key concepts, the tools, but also how you design the exercises to make it more engaging for your audience. We are also having 2 demos for QAMyData and SDC Micro. And I have to say, this morning, I was trying, it's part of the presentations as well, trying SDC Micro because I always try the tools on the morning before, and I was playing with R a couple of days ago, installed more packages and the GUI would just not open. That was almost gave me a heart attack. Ended up having to uninstall all the packages and it working. So with R and with SDC Micro, this is a lesson learned. When you are installing a lot more different packages, there can be clashes between the packages of R. It happens very often, and it's not only an SDC Micro problem, I would say with any package that you might use. So the main objective of today's session is to enable trainers to introduce in their research data management training the context, the concepts, exercises, and tools for both numeric data quality assessment and disclosure control. But this one, I think, is again taken for granted. Everyone understands where people might be referring to different things when discussing the same things. Tools, and again, I'm here referring to choices. While you would teach on a tool that your organization is using, that you're feeling comfortable teaching with, it's always good to give people alternative tools that are out there. They might not necessarily do the exactly same thing, but similar things. Because what happens is, if you teach a tool that for you is second nature, everything works fantastically fine, someone might actually not understand the tool and they might be put off tools in general, but giving them that choice of tools offers them there are others out there, I'll give them a try, and they might actually be able to use other ones better. And also, how do we do exercises when it comes to data quality assessment tools? Now, in terms of the context, planning and documenting always comes in handy to present to them why do we do this data quality assessment and how does it all start. So it actually starts from the planning and documenting stage. And again, the Data Management Expert Guide Chapter 2 covers the planning and documenting extremely well. You can point them to that. You can reuse the materials. It covers things like implementing good practices in a consistent manner, assigning roles throughout the research, making sure that you know what everyone is doing, that designing data management according to the needs and the purpose of the research is extremely important. And again, especially with GDPR or UK GDPR, it's really important to bear in mind privacy by design and data minimization. Do they actually need to get all this data collected, or could they not collect all the personal data or sensitive data, depending on the topic? Also, it's really important to stress that throughout the research cycle, one needs to incorporate good data management measures. Because if you don't have, for example, any variable and value labels when you start working in your data set, that might be confusing, because how are you going to do your own analysis? But it happens, we've seen that in the past. Once you want to share that data, it becomes a really long-winded process. You need to start basically from scratch to do everything. It's always good to mention the open science agenda. So as we've seen now, funders, professional societies, journals, they are asking for the data to be shared. You can't just share any data. So you can't just share a CSV with no documentation whatsoever, because while yes, you're sharing your data, otherwise won't be able to use it and is not actually reproducible. Replication policies do exist for psychology, economics, and political science journals, especially in the UK. And we've seen quite an increase in archiving very good quality data when it comes to these main subject areas, because they know peer reviewers will want to see the data, they will want to replicate what they've done. Very good to include the FAIR principles into your talks. It doesn't need to be something very in-depth, I would say, but just making people aware that the FAIR principles exist. It's really important to follow them. How do I make my data findable, accessible? They are all documented there. And actually, and I do apologize, I realize I haven't put the link in the presentation, but I'm going to add it before I'm sending it via the email. There are a couple of tools that enable researchers to check if their published data is fair. There's the Fair Aware tool and also the Fuji tool. The Fuji tool is more machine readable, and it actually actions on the DOI or the URL of that specific data entry, and it gives different scores for different areas. It's still in a beta version, but I found it most fascinating. I do enjoy using that tool. Now, data review, again, depending on your target audience, the context and the key concepts you are introducing in your training is really important to align them based on the target audience, the people you're having attending that specific event. Because I take, for example, for granted, data, why do we do data review? Where can I find issues? But for newer people, for people that are just learning now about data curation, it's actually quite important to explain to them, well, it's not only about just the data issues in itself. There could be file issues. We could have personal data embedded in the file as well. There can be disclosure control issues. So here we're talking about confidentiality and privacy concerns. It's good to mention, again, in this links back to the planning document, that every data set that has personal data collected requires a data privacy impact assessment under GDPR, and it's very good to plan in time for that. Again, the data privacy impact assessment, while it might seem onerous on the researcher side, it actually helps ensure we are getting data that we should be collecting, rather we're getting too much personal data that's not going to be of any use. It's also very important to mention to them about access safeguards, because again, I think with the open science agenda, while yes, as much as we can have data open under a CC BY or open government license, that's fantastic. Sometimes we need the access safeguards in place, and depending on the institutional repository or the data archive you're coming from, everyone has a data access policy in place with different levels of access. Or if you want to deposit via a specific repository, consulting the different levels of access they can make data available to is very important, because with UK Data Service, when there is this residual disclosure risk that is very close to zero, we can actually make the data available under safeguarded access. So only registered users will be able to download the data, and they must ensure that the confidentiality is kept at all stages, but also contact us if they find any problems or issues. But we also have, especially with very granular research, different organizations need to share what is classified as personal data, because it's not anonymized, it's only de-identified. So we just remove the direct identifiers from it. And for that, we have the Secure Lab. We call those data assets control data assets. They're made available via the 5 Safes framework, for example, which only allows accredited researchers that are trained, that have their projects vetted by the data owner to access the data into the safe haven. So they can't download the data, they can't take it anywhere. And even their outputs, so all the results they want to publish, they are actually checked by our user support team for disclosure issues. Today, we're focusing on input disclosure control, so the big data set, not output disclosure control. That's another dark art area of disclosure control. I mentioned concepts. I think metadata is the concept that is usually missing from any presentations on data quality assessment. And I think it's quite important to include. It doesn't need to be extremely in-depth. Maybe if they're very new starters, such as master students, it would be good to have more information about this. But it's good to know that they make the difference between the different types of metadata. We have structural metadata and we have reference metadata. When you check the data itself, we check the structural metadata, but the reference metadata, the catalog metadata, is also important. Really important to bring to their mind that data level documentation is about information about all the data files and the description of variables in the data files, value labels, variable labels, etc. Embedded data documentation where possible, and I am a keen open source person. So while we know, of course, SPSS and Stata do this amazing, there are actually open source alternatives such as R and Gretel, and there's also an open source version, an open source tool trying to recreate SPSS, PSPP, which again, people don't need a license for it. When it comes to higher and further education, Stata and SPSS are fine because they're provided by universities. But when it comes to other types of researchers that are not involved in higher and further education, they might struggle with getting licenses for such software because they're quite expensive as well. There is further information in the Data Management Expert Guide about documentation and metadata. And in here, I did not provide the Zenodo link, but I've provided the CESSDA webpage link, which is very, very friendly and easy to follow. Now, as I specified, it's all about choices and preferences. Try to make your trainings as engaging on an individual level as possible, obliging people to do things they might not want to do. It is never good. So while you might, for example, be teaching on QAMyData, it's good to say to them, well, actually, we have OpenRefine and Dataverse, the Dataverse curation tool as well, which are great. They can do X, Y, Z. However, we chose QAMyData because this is the tool that our organization is using, or this is the tool that we're familiar in. Always try to present a tool that you're familiar with rather than a completely new tool. Now, QAMyData started as an NCRM-funded UK data service project. It's all under open license. People can take it, enhance it, do whatever they want to it. It's basically providing this data health check, we like to call it, that identifies the most common problems in data that we got, but we've also done consultation with different other repositories to see, for example, what are the main problems they struggle with. And especially when it comes to smaller repositories, it's extremely fantastic and of use to have this tool which you run. You can see where the problems are, going back to the data owner, the data depository, and explaining we would need more information here, or there. It does support researchers both from a creator and user's perspective. It does support data reviewers and publishers as well, and is helping set up data quality profiles for data publishers. So for example, I'm only accepting if all the variable and value labels are properly labeled, otherwise I'm not accepting that data set. The tool itself can be run on popular file format, SPSS, Stata, CSV. We chose SPSS and Stata because, again, especially in the social sciences, they're the main ones used. However, we do see a drive on moving on to CSV, especially with the open source tools. It does not change the files. Once you run QAMyData, it's not going to change anything in the files. It's just going to flag potential issues in your file. So it still needs this human component to it. It's not like I give it my file, it does its thing, and then it's ready to be published. It was written in Rust, and the tech behind it, our tech developer tried different tools to write this coding, and they went with Rust because it's the fastest one available. It started to be more widely used now, Rust, and again, it's all very well documented on the web, so it's really easy to add on to the tool if one wants to do so. The configuration file itself is written in YAML, and we're going to see during the demo, it's very easy to configure that. It's basically you open it in Notepad++, and you can configure the different tests that can be user changed. Very important, it is currently dependent on command prompt. We do not have a graphical user interface at the moment. We are trying to get some funding to develop that, because I think a graphical user interface would allow more people to use it. So, for example, this is a lesson learned as well. I've learned while teaching that, for example, government department or public bodies, they're not allowed on their institutional machines to use command prompt. They need to use separate machines. So it's always important to bear in mind that it is dependent on command prompt, at least for now, while we don't have a graphical user interface. When it comes to the checks that it's doing, so of course it checks if the file opens, because otherwise it will not run the check. It has a file name check, which we defined as only taking A to Z, 0 to 1, and underscoring, because at the UK Data Service, we use Nestar, which is a dissemination tool, and being based on Unix, it doesn't allow illegal odd characters such as star in the file itself, in the file name. So that's why we decided to put that file name check in. But again, that can be changed. So for example, if you would want your file names to be prefixed or something, that can be changed by using regular expression. It has data integrity checks, and it prints at the bottom the number, at the top the number of numeric and string variables. It actually displays if you have any illegal characters, and again, these are user defined. For example, we really don't like ampersands in our variable and value labels because it messes up again with Nestar because of Unix. So we always check for that. The spelling mistakes and truncation, we do have data dictionary in there that should run this. There was a dependency update not too long ago, which made this not work quite as expected. So our developer is looking into that. It does point to empty variables, as in variables that are set as system missing entirely. And this is a test which is extremely useful from a user perspective. We get a lot of data owners that instead of deleting the variable from the file because it can't be disseminated, it's personal information or it's too sensitive, things like that, they actually set the entire variable as system missing, which is really confusing from a user perspective. Why is that there? Will it come in a new edition? So it's really good to have that printed out. It does check for missing variable labels. It's going to prompt us, oh, you don't have variable labels for X, Y, Z. For invariable variable names, sometimes SPSS oddly accepts some invalid variable names, which when you're trying to run a frequency don't work. So it's always good to have that in as well. Missing values labels for defined missing. So here I'm talking about -8 and -9 that are, I don't know, in missing, for example, that don't actually have this specific value label added in. And this works for SPSS because SPSS makes the clear difference between the defined missing. And we also have disclosure check. It actually checks for direct identifiers using regex. And we're going to see it's very user customizable. So you can, for example, want to search for phone numbers or for email addresses. You just put the regex in there and it's going to see if it finds any for you. Now, the important thing with the direct identifier is because it runs on a regular expression, it does take time to run. So if you have a huge file, it's always advisable to not run more than 1 or 2 different regex checks, unless, of course, you have a supercomputer that runs extremely fast, and then that's totally fine. And it also flags all the unique values in continuous and categorical variables. So for example, if in my age variable, I have someone that's 120, it's actually going to prompt me, well, you have this outlier here, and then I can decide what to do with it. It's very easy to install from GitHub, and the wiki has documentation and instructions for installation. And I'm going to show you the UK Data Service page as well. And in the Google Drive, I gave you all. We also have the install and run guide for QAMyData, which is, while the Git page is very techy, I would say, the user guide is more user-friendly with a lot of screenshots. The code is licensed under MIT license. So again, if you have someone in your team that really likes tech development and they would want to add different tests, from what I understand, I'm not a tech person myself, it's quite easy to add these different tests to the tool and make it more approachable for your own checks within the organization. It can be partitioned off from other resources. So we could put it in a pipeline, and the idea behind QAMyData as well was to actually using in the deployment for big data, a big data pipeline, because it actually checks any disclosive data that might be in there with the regular expression checks. And the Australian Data Archive, they've actually provided a graphical user interface, and which allows you to upload the file. It's locally, it doesn't upload it somewhere on the internet, but it doesn't allow the change of the configuration file, and that's something that we are working on. The QAMyData live demo, I'm going to stop the share, everything open. So as I said, QAMyData is dependent on command prompt. It currently runs only from command prompt. So it's really important to ensure that you can use command prompt on your machine if you're using an institutional one, or that you get the admin permissions to do so. So once QAMyData is installed, and again, I've seen a couple of people saying they don't have the tools installed. If you would like the tools installed because you want to do the hands-on exercises, please do drop me a message and you can have a look over the break. I can even demo the install of the tool. It takes 5 minutes, so it's nothing too complicated. So I have QAMyData installed here. What's really important is to actually point my command prompt. It prompts me to my M drive. We need to put it onto our A drive, and then we need to change the directories to where QAMyData is installed. Now, because my spelling is awful, I do like to have a notepad open, and that's how I usually teach it to students, etc. Open a notepad, look in the user guide or in the exercise we gave you. It clearly states what you need to include, but don't just type it yet in command prompt, because if you type something wrong, it's not going to run, it's going to panic. So it's better to type it in a command prompt. In order to run QAMyData, the QAMyData run is needed. That is basically telling QAMD run this file. We need to specify where our file is. And as we can see, this is in quotation marks. It's just the path to the file name here. And don't forget the extension of the file. So you can run data as well in CSV files, but I'm choosing the SPSS file because that provides more information about metadata at the data file level. Now we need to put our output. We see we have -- output. This is telling QAMyData how the output file should be named. The default output is HTML. QAMyData is able to print JSON as well, but JSON is machine readable, but it's not very human readable. So using HTML, you can actually see exactly what QAMyData is giving. Finally, it also needs prompting to the config file. So we have -- config. And as for the location of the file, we need the location of the configuration file that we need. In our case, we'll first be using the default YAML. So I'm happy with this. I know I spelled it all correctly. It's not going to scream at me. I can put it in here. It's going to prompt me with a nice loading bar telling me, oh, I'm thinking about it. I'm running it. I'm doing it. Because we changed the directory to where QAMyData is installed, the result file is going to be printed here. So that's why we changed the directory. We ensure that everything is kept together. So if I open And I hope you're seeing what I'm seeing. Yes, I just had to double check that I'm not sharing something else. This is how the output files from QAMyData looks like. We see the raw case count, so how many observations do we have? Again, this took a bit because we have 35,000 observations. We have 140 variables in the files that I've used. This is the demo, this is not the teaching one, so you'll get different results. We do have data type occurrences. We have 135 date in string dates as well. We can see when the file was created and last modified, and we can see file encoding, and also we can have a file label. Not a lot of people are putting metadata in regards to file label, so that's usually empty, but we can see if it has a file label. As mentioned, the bad file name, that's how we called it. It checks if I have any spaces or illegal characters, which I have. This is the demo data set I'm using to basically follow as many things as possible, just to show how QAMyData is working. We can see we have 18 variables with no labels, and by clicking on there, so I'm going back up, just clicking on this, it will take you down to the list of all the variables that do not have any labels. So again, if you are reporting back to the data owner, you can copy this over. You can send them the HTML as well, and they can see for themselves when things are failing. Now, if I open the configuration file, because as I've said, it's very easy to configure the YAML config file. I usually use Notepad++. I like it better when it comes to formatting and everything, but you can use Notepad as well. That is not a problem. We can see we've divided the different checks in the file as basic file checks. Of course, checking the file opens, that it does it automatically. We didn't have to include it in here. And in here, as I said, if you want a different pattern, you can search for a regex that fits your pattern and just add it in here, rather than the one that only accepts A to Z and 0 to 9. Now, metadata-wise, we can check for high-level grouping. So if you have, for example, a household ID in the data set, the teaching one or the demo one, there's no grouping variables, so we don't need to check on that. You can comment out a specific test just by putting a hash in front of each line. That comments it out. It basically means I'm not going to run this. You don't need this from me. Now, the variable should have a label. Again, that automatically run. Value defined, missing with no label. Again, this is for SPSS purposes only. When it comes to different illegal or non-compliant characters, however you want to call them. For example, you want this, but you also want, I don't know, let's say this one. I'm not quite sure how this character is called, but as we can see, we can just put it in here. So it's a line, and then we need to put the quotation marks in whatever we want. We don't want M's, for example, and it's going to prompt us how many variables have M in their variable names or label. The same test is done for value labels as well. And usually, because again, it depends on what different other tools your organization is using or the researcher is using, usually them two will be the same. So if I'm not accepting something in my variable label, I'm not going to accept it in my value label either. Max label. We've used this because with UK Data Service, we provide data in SPSS data in tabbed limited ASCII format. And for example, while SPSS accepts quite long labels, Stata cuts them off at 79. To ensure consistency over the files, it's good to cut them off at 79. And for value labels, Stata cuts them off at 39. So keeping them quite short and consistent. Now, again, this is not compulsory. If you're just using, for example, SPSS, you don't need this. Again, it can be just commented out, and that's fine. It's not going to run that test for you. The spell check, as I said, currently, please do ignore this, and I do apologize, but it's now checking for spell check and truncation within the string variables rather than the variable label. That's doing, I mean, it's good for string variables, definitely, if you want to check for spelling mistakes and truncations in there. And all you'd have to do is check where you have this dictionary file, and on GitHub you can get a lot of different dictionaries, English dictionary, etc. And the QAMyData default build actually comes with the English dictionary in anyways installed, so you don't need to worry about that. You would just need to put it in there. If it's another language, GitHub is the place to find it. Data integrity. We can actually set what is our unique identifier. So for example, I have ID or something. In my case, it's actually case now. That's the ID in the demo file that I'm using now. And this test actually came after workshop with some data health professionals that they said in the clinical trials data, it happens, and it's one of the big mistakes they see going on, that they have duplicate IDs, and they really wanted to check for that. It was really easy to implement, so it was added in. Again, we can check for the same or the legal characters in our string variables as well, and if we change the previous one, we would expect it to be the same. These are the main ones that at UKDS are not so accepted, and usually the ones that cause problems. We can see as well in here, we have the @ which comes in very handy if you have email addresses. It's actually going to prompt you to all the variables that you have that have email addresses in, as long as they have the @ sign. But also, when it comes to the @ sign, you can actually do that under the disclosure control checks. In the file itself, we have a check for email addresses and one for mobile phone numbers. Now, those are just the two common ones, but the regex library, and this is the main page here, the regex library provides a fantastic resource on finding exactly the regular expression that you want to use for something that follows the regular expression. So again, I'm talking about phone numbers, email addresses, postcodes. You can search for postcodes as well. And they do differ from one country to another. So it's good to search, for example, mobile numbers UK. This is something that we would see. Oh, no, it did not like that number. As I said, my spelling is not great. We can see in here UK mobile phone number, India phone numbers, Indian phone numbers, South African mobile numbers. So we can find all different types of regex checks on regex library. This is my one of choice. There are a couple of more libraries out there, and there's actually a library on GitHub as well that provides different regular expressions, and that can be used as well. I do like regexlib because it has the user interface and everything. So I do like using this one. Going back in here, so if, for example, we want to use the check for any email addresses, and we're not actually checking for @ in our string, what is best to do is do not save the default one, because if you save the default one and you've mistyped something or you've commented out something not as quite it should have been, then it doesn't run anymore. You need to download QAMyData again to get the default configuration file. So what is best to do is to either save it as or create a different configuration file, which you save under your config here. As you can see, I have different ones because I like to test different things. And we have the email address one in here. And if we go lower down, just here, we can see we've just left the email addresses. It does have this @ here, basically pointing at something, something, @ and then something, something, .com, or something that's between 2 and 4 characters. So if I go back to my QAMyData, to my command prompt here, I can actually run QAMyData with this new configuration file. And again, I actually have it written in here. Make sure my spelling is okay. Command prompt doesn't come back saying, I don't know what you want from me. Now that it has regex in, it's going to take slightly longer. And when I say slightly longer, it's probably a couple of extra seconds. If you run a lot of regex, it can take a few good minutes. But if you just run one, it's just going to be a couple of extra seconds, especially with a file such as the one that I have. It only has 35,000 cases. And I will have to restore this. And we go to A. And we see D to where QAMD is. Taking a bit longer than usual because we know it ran once it prints the this arrow here, the bigger than sign. That's how we know command prompt ran, but it doesn't seem it wants to run, which is rather odd. I've tested it this morning, making sure it works, and it only took, I think, 10 seconds extra than the one without the email address. Because again, it's that regex that is making it take a bit longer to run. Because we're losing time, I'm going to start the lessons learned. I'm going to let this run in the background and come back to it. So I'm going to do a new share. I do apologize. There are very many shares here. New share. And we have the exercises when it comes to QAMyData. Use a small teaching data set that is edited by you to contain common metadata and data integrity issues. So for example, we're removing the variable labels for 5% of the variables. That provides a good example for them to realize, oh, that's a problem. Create some duplicate IDs if that is something that would be common for your users or for your target audience, better said. It's always important to include things like that in. Ask them first to manually identify issues. And you're going to see the exercise today, which again, you're more than happy to use the hands-on one. It actually asks you first to go over the data files and identify all the issues you can in 10 minutes, and then ask them to use the curation tool, because it shows how fast a tool like QAMyData can actually flag all the issues in the data file. Also, do have a discussion around manual and semi-automated checks for data. And I would say the discussion is extremely important if you are teaching this to people that actually curate data as a job, because with QAMyData or any other tool like that, it's not about stealing someone's jobs, it's making someone's job better, because it does need the human input. So it's not like their job is redundant now. No, your job is going to be a lot more better because you don't need to spend hours looking at the same thing. When it comes to exercises, do try to use different tools: Mentimeter for polls, Padlet for responses, ideas, clarifications as well. You can have anonymous Padlets, and mirror boards if group exercises are designed. But actually, for bigger groups, I would say if you have 10 people in a group, mirror board can come in very handy. If they're very big groups, then having different mirror boards, because it can become a bit confusing, I would say, with too many on. Now, time to go _2 is our new file. We didn't override the previous one. And if we go lower down, we can see it now included the value regex patterns, which is not included in the previous one. I'll just open the one as well. because in the default one, regex is commented out, so we can see it's not here, but it actually included it here, and we can click on it, and we can see that this var one variable in different numbers, it actually contains email addresses. And that's true. It's just a fake file I've created with email addresses in. And we'll see the teaching one doesn't have email addresses, has something else. And from current slide, participants. It's really important when you design your training to actually think who this training is going to be for, because it changes the content of the training quite dramatically. And it also changes the different timings that you need to set for different areas of the exercises. And I'm saying that because, for example, if you're doing a training with data professionals, the manual checks can easily be done in 10 minutes. They know what they're doing. They're going to use a tool of their choice. They know what they're doing, and it's fine. When it comes to students, it's better to give them more time for that, because again, we don't want to stress them. We want them to embrace checking data. So give them the time to do that. And again, the time for QAMyData will need to be slightly longer as well. Do deliver different sessions for different audiences. It's quite easy once you have a specific presentation done to keep reusing it as it is. It's not making it from scratch by any means, because most of the information is going to be the same, but just including more detail about, for example, key concepts. I want to touch more on metadata because they're newer, or I just say, well, it's going to check this type of metadata because the data professionals, they know what I'm talking about. And again, in terms of the context as well, if we're talking about data professional, the open science agenda is really nice to include that with even more detail. They want to find out more about FAIR principle. They will potentially use FAIR tools, so including the Fuji tool as well in your presentation might be actually of extreme help to them. So it's always thinking about what your target audience is, what do you want to include in. If the hands-on is time limited, do set prerequisites like basic knowledge of RDM and highly computer literate, and always ask for the pre-install of any tools. Not having the tools installed, and if you design a session only with hands-on exercises, that can lead to delays. If, for example, you have many people that don't have the tool installed. Choice of tool, again, as mentioned, do use something that your organization is using. I am presenting on QAMyData because this is something that we use in our curation workflows. But if your organization is using something like the Dataverse curation tool, to present something like that, and always give the different alternatives. Oh, there's this out there and there's that out there as well, if you would like to use them. If whatever tool you're using doesn't have a user guide that's friendly, so for example, if you're using a newer tool that's only available on GitHub, then GitHub tools usually have quite tech documentation rather than very user-friendly documentation. So do try to prepare one. It doesn't have to be thousands of pages, just 5 pages going over the tool, what it does, how it does it. And also potentially writing anything that might go wrong. How do you troubleshoot if something goes wrong? Do always take into account if the tool is dependent on a stable connection, especially when you're training face-to-face, and if the tool needs admin permission in order to be installed. Do request pre-install if it needs admin permissions. Now, disaster scenarios, and again, this is lessons learned from previous experiences with teaching on quality assessment tools. Do have the latest version of the tool installed on your machine and test the day before the course. If it's a very I would say used tool, it's better to check it on the morning as well, in case an update came that morning of your training. It can happen, especially with GitHub or R tools, because they have a lot of dependencies. So while the tool itself might have not changed, the dependency could have changed, and that might break something. And it is very good to check. if you're having face-to-face training, and I know potentially we're still quite far away from that, try to have a few spare laptops with you with the tool installed in case someone's laptop isn't working, or they decide to have Windows updates for 2 hours. It happens. So always have a couple of spare laptops with you if possible. If online, you can actually prepare a few servers. This is more when you're teaching, again, I would say more early career researchers, students, rather than data professionals, because it's quite nice to have them have the tools installed and even troubleshoot installing, because it teaches them there's a solution for everything. But if needs be, having a couple of servers which can be remotely, or setting up virtual machines and asking people to have virtual books installed on their own machine, that might help. Do have backup exercises which do not require the use of the tool. And again, dependent on the audience, if your main aim of the session is to teach other people to use the tool, there is no point in having backup exercises that do not require the tool. In that scenario, you would actually have the tool archived properly, so even if it gets updated, it still works. So there's some extra steps, but if your main aim is to actually teach that tool, you do need to have hands-on exercises for that specific tool. And now we have, and I apologize, it's only a 10 minutes break rather than a 15 minutes break. I do get very excited. And once you teach on disclosure risk assessment, it's really important to consider the objective of including in your training, and ideally even in your advertising of the session, things like objectives of the session. It's really important to put objectives of the sessions when you're focusing on disclosure control, because it does happen for people to think, I am going to attend this session and I'm going to become a guru of statistical disclosure control, or not them themselves, but the employer might send them to a half a day or a day session on statistical disclosure control, considering that once they back, they know everything there's to know about disclosure control in numeric data, and they can use a tool and fix all the problems. Sadly, that is not the case, and it's all about training, of course, as well, being trained in this, but also doing a lot of reading and doing a lot of different exercises in order to see what works and what doesn't work. Again, as for QAMyData, including the context, why do we do disclosure risk assessment? Why is this important? Some key concepts and the difference between QAMyData and SDC Micro disclosure risk assessment in general is that there are a lot more key concepts when it comes to disclosure risk assessment. What tools they can use, and we'll see SDC Micro is purely chosen because this is the tool that we use at UKDS, and I'm going to go over why we use SDC Micro as well, why is the chosen tool, but there are other tools out there as well. Some are especially easy to use as well, so there's no right or wrong, it's just a tool that your organization is using. And also, what kind of exercises do you need to include to actually help the audience understand what you're talking about? Again, disclosure risk assessment is a very complex topic, and I would say it can be quite difficult to include a lot of information into tiny sessions. So when it comes preparing training on disclosure assessment, give as much time as possible, go over the concepts as you wish, allow others to ask questions when needed. And of course, if there's anything unclear while I'm talking, do unmute yourself and ask any questions. So as an example, if you're running a half a day session, a 4-hour session, the objectives would be for the target audience, you're making them aware of all the issues in consideration when it comes to the statistical disclosure control. They would gain basic knowledge of the key concepts. And again, the key word here is basic knowledge. We're not doing anything extraordinarily advanced. They will be able to start making principal judgments, because once they have the key understanding, this is a direct identifier, this is an indirect identifier, oh, this is a proper combination, then they would actually be able to start these principled judgments and also be able to start to find the balance between minimizing the disclosure risk and maintaining data usability. And this is the most difficult thing, I would say, when you're teaching on disclosure control, because it can go wrong very abruptly, I would say, while you can use tools to do very quick, and we'll see if CESSDA Micro does this as well, a very quick treatment to your data, which is fantastic. The chance of re-identification drops extremely low. There's very low usability in that data. So what's the point of sharing a data set that's not used? And disclosure assessment is about common sense, seeing that individual risk within observation and making that principled judgment. Should I actually ban or aggregate this, or should I leave it as it is? When talking with them about the context, it's always important to define why we're actually assessing this risk when it comes to data sharing. It's not only from an ethical and legal standard, but it's actually very important in deciding how to share the data. As I've mentioned, we were just talking about different safe havens approaches and how different organizations have set up different safe rooms or safe havens, as they call them, in order to enable access to sensitive or potentially personal data. So always give the target audience the option to understand that while, yes, if you want to share this data via a safeguarded pathway where only registered users can download the data or open data in some cases, then you need to apply XYZ. When it comes to actually making potentially personal identifiable data available, of course, as long as you have a legal basis in place for that processing to take place, there is the option of providing access via a secure lab safe haven environment, because the risk in a single data set does increase because people do need granular level information. They do need this personal level information. The more, the merrier. Providing banded ages is fantastic. It's still very useful. But some people, while banded ages are quite, I would say, standardized, some researchers might need different ages or different age bands, or actually the raw age to include that in their model. People are often interested in unusual and rare occurrences in the data, and this is extremely applicable to clinical trials data and health data especially. So we'll see when we talk about K anonymity, it's not like, oh, I can magically press a button, make everything 5K anonymous, because again, it's about data utility as well. And of course, the biggest risk when it comes to data that is shared outside of a safe haven. So in a safe haven, they can't access anything else. They don't have access to the internet. They can't see Twitter and Facebook and things like that. When you're making data available to share for others via download, then they have access to everything else. So potentially they could link social media data with the data that you have in your data set. Now, reasons for assessing disclosure risk is not to make people afraid, is to make people aware that they need to do this. And it's quite good to insist on, from an ethical perspective, you need to protect your participants. From a legal reason, we have legislation, European GDPR, the UK GDPR, data protection, different types of acts. We are not allowed to share this personal data unless, again, we can have a legal basis to share personal data. And we link it to safe rooms as well. We can't just share that data wherever. There are cases where consent for sharing the raw data as it is actually feasible, but usually that is more likely with people that are already known. So I don't know, politicians, celebrities, and it applies a lot to qualitative data rather than quant data. And again, we're talking about GDPR as well, data minimization. Do I need to share that? So it's all about making this principal judgment. And of course, we have the commercial reasons as well, because a lot of the data that is made available via safe havens is actually business data. So there's a lot of commercial risk there. Oh, they will find out we had this turnover because of this. The data sets are extremely rich. So we couldn't share that unless with strict regulation on. Now, again, linking this to legislation, I think especially once GDPR became active, more and more people understood, well, actually de-identification, I'm just taking out the direct identifiers, names, addresses, but anonymization is completely different. It's a whole process, and I need to ensure that I'm making this new data with a very, very high level of re-identification possible, basically as close to zero as possible. There are four main types of anonymization. We have formal anonymization, guaranteed anonymization, statistical anonymization, and also functional anonymization. Today, we're going to focus on statistical anonymization and the concepts around statistical anonymization because we're using a tool, but also touching a bit on functional anonymization, again, safe havens, access safeguards in place. Formal anonymization can also be known as de-identification. Now, whenever I teach on disclosure control, my main thing is if people go from that session knowing that when using a tool, you're never going to get zero global risk. I'm happy with that. It's a mathematical formula, so you're not going to get that zero. That there is no thing as zero, factually speaking, when it comes to disclosure control. But our main aim is to minimize this residual risk of disclosure as much as possible, be it 0.05. But again, it's never going to be absolute zero. And that's the basic principle of statistical disclosure control, that it is impossible to reduce this probability of re-identification to absolute zero. So instead, you need to control or limit the disclosure risk and the disclosure events that might happen. Types of disclosure is really good to let your audience know there are actually different types of disclosure. So we have identity disclosure. It happens when you actually have direct identifiers in the data. So I'm an intruder. I got this data and I want to identify someone. And actually you left in email addresses, which I can Google, and I can find this person has an Instagram account linked to it. I have successfully identified that participant. I am completely 100% sure of that. That is identity disclosure. We also have attribute disclosure, when the intruder is able to find out some unknown or sensitive information about our participant based on the info in the released data. This is not 100%. There are no direct identifiers in the data, so I'm talking here about what is to be considered anonymous data, but they could potentially find out someone has HIV or any sensitive information, criminal records. So this is the one that we're focusing on today and while teaching on statistical disclosure control, because the identity disclosure is not going to happen. We don't have direct identifiers in the data that we're going to share. Giving them some examples of direct identifiers and indirect identifiers, it's always useful because, again, we might take it for granted, and of course, VAT number is going to be directly identifying variable. There's only linked to one person, so we know that. But it's good to give them a couple of examples to put them in their mind, especially when they're going to have hands-on exercises. Now, when it comes to indirect identifiers, and this is where it becomes, I would say, problematic, and it's good to take as much time as possible to allow others to understand what possible combinations would be generally tested in different data sets. What I usually do, again, depending on the target audience, but I include quite a lot of exercises about this and the differences, and a bit of discussion as well to get people thinking about, oh, this is a direct, this is an indirect. Oh, people can be identified by using this in combination with that. And we do like to refer to indirect identifiers as sensitive information and maybe less sensitive information, age, education, employment, and of course, sensitive information. All the things that are considered under UK GDPR and European GDPR special category, such as medical condition, crime records, but there's also sensitive information such as income. Now, from a statistical disclosure control perspective, variables can be categorized as direct identifiers, key variables, or non-identifying variables. Direct identifiers are the same, again, IP addresses, national insurance numbers. Key variables, however, are all the indirect ones. And again, this is dependent on a case-by-case data set. You can't give them a full list of all the possible indirect identifiers because they can be many, depending from the topic of the data set as well, but giving them examples. So thinking what kind of information do I need to identify someone? Well, if I have their age or their date of birth, that's even worse, and their specific education level, their employment details, where do they work, how long have they been working there, what kind of religion they are, what's the household size they have. So all of this, when put in combination, yes, especially when combined with information from social media, can lead to the identification of an individual. Now, when it comes to household size and usually household information, it's very good, depending on the country you're based, to check the different numbers on a census level. So here in the UK, the Office for National Statistics actually provides guidance on what is considered disclosive when it comes to a household size level and what's considered less disclosive. So overweight 8 is quite disclosive, over 10 is super disclosive. But this again depends on a country by country basis. And it's something that is really hard to assess when receiving data from other countries, and where we need to take the advice of the data provider, of the data owner, of the data producer, because they would be the one to know, would this be disclosive? They know their sample, they know their population. So it's always a discussion. It's not one-sided, it's a discussion with the data producer as well. And of course, we do have non-identifying variables in our data sets as well, such as does your fridge work? We're going to see we have one of those in the demo data set, but there's more and more literature that is saying that all of this, what are now classified as non-identifying variables, are actually contributing to a higher disclosure risk, given that when you put them together with the key variables, they provide even further information about that specific participant. Now, when it comes to methods, do give them an overview of what's available. They can use both data distortion methods or metadata level methods. It's either up to them, especially as a data producer. Data distortion controls can be easily used, and I'm talking especially about adding noise and post-randomization. Both adding noise and post-randomization, they require someone knowing the data extremely well. Yes, SDC Micro can do it for you. However, you would need to ensure that that PRAM is actually done properly and you document it in your documentation. I could only make available my data after I post-randomized it. It changes the values. So you need to give the specific equation of what the program did for you, for others to be able to use that data. Some data owners do use that. And I know for the census 2021, in the UK, they were actually looking whether to post-randomize and add some noise to make more data available under open or safeguarded access. They do make control data available as well, and that's the very detailed raw data. There's also the possibility of microaggregation for continuous variables, which mostly is done by repositories. Is something really used by service providers. Again, with the consent of the data owner, no one would change anything on the data without the consent from the data owner. There's also the possibility of cell or value suppression. So instead of, oh, this variable is too disclosive, it's actually just one individual, which their combination of variables makes it very disclosive. So I need to take this cell out. I'm going to, instead of saying, yes, I own 3 cars, I'm going to just put it as an NA. Again, number of cars, do pay attention with that. There are studies that actually allow for not top-coded number of cars, which becomes problematic when put together with other variables, though it could potentially be a non-identifying variable. Non-perturbative methods, also known as the metadata level controls, are the ones that are most widely used, I would say. It's all about reducing that level of detail in the data. So we are recoding some variables. We can create a sample. So instead of making the entire data set available for reuse, we're sampling that data. We document how we've sampled it and everything. It's available in the catalog record where we publish our data, but we've sampled it. So it makes it less disclosive. And we can see, again, a good example here is census data made available under open access. They're usually samples and not the entire population, because then it would be too disclosive. And there are situations where we have to remove specific variables, but also to bear in mind, we remove them from the version that we want to make available under open license for everyone, or under safeguarded, a standard end user license for registered users, but we can keep them in controlled environment and make them available for reuse in controlled environment. It's always good, especially as you're bringing them so many key concepts. Some of them would be quite confusing to grasp at the beginning. It's always good to go back and try to set them out in very easy terms. They have probably done this before. Aggregation, for example, most data has some sort of aggregation from it. For example, we have the urban rural instead of having the specific place where they are, or government office regions in the UK, rather than having the postcodes. Government office regions, they're really big, so they pose no problem when we're talking about quite a high sample of people. That's one of the most widely used geographical variables in safeguarded data. Banding ages, banding income, anything that could potentially at a lower or upper side have outliers, and we see that very common in income. Quite a lot of outliers, and also with ages, we do see studies where someone, for example, is 108, and it's actually quite easy to Google because there are not so many 108, even if it's government office regions, living in London, for example. So we would actually band those upper and lower ranges. Use standard coding frames, and the examples I'm giving here is the Social Occupational Classification 2010 for employment. That is something that is used in all of the large-scale governmental surveys in the United Kingdom. Every country has standard coding frames for different variables. We have religion, for example, as well. For UK, it's quite easy. The Office of National Statistics provides all of this information on their website. So it's really easy to get a hand of. And using the standard coding frame not only is of help when it comes to statistical disclosure control, but it's extremely helpful when it comes to harmonizing data from different countries. So it's a double usage there for using standard coding frames, rather than we get studies where employment is initially just a string variable and we have 10 people spelling accountant differently. I would, as you've seen, my spelling is completely terrible. So I would definitely be spelling something wrong. So using the standard coding frames is really important. String variables are sadly our biggest enemy when it comes to disclosure control, because they contain a lot of information. As we see in qual data as well, it's really hard to properly anonymize qual data. When it comes to string variables, generalizing the meaning is always an option when we're talking about making that data as widely shareable as possible. So we wouldn't share string variables under the safeguarded level unless they are very short, with no sensitive or potentially personal information in them. It is possible. There are a lot of teachers, especially with moving to remote working, doing surveys about how students are finding remote teaching. And they do have string variables, which are extremely clean, extremely okay to publish even under an open license. There's nothing wrong with them. But when we start looking at especially bigger research organizations and government data, string variables can become problematic. And we were discussing this in the breakout room. But also I've seen it before I started being the collections development manager, I worked in the curation team. I was a senior curation officer. So my main job was to actually curate data from large scale government data in public bodies. And a lot of the string variables there are basically asking things like, why are you not receiving pension? And then they do start going on about how their son Andrew moved to Connecticut because they got a job with this specific organization, and they did this and then they did that. So string variables are your biggest enemies. Hopefully QAMyData helps, because even when you want to share that data via a safe haven in a controlled environment, that data would still need to be de-identified. So we don't want names, we don't want email addresses, phone numbers. And hopefully QAMyData helps with that, because you can use the regular expressions to actually check if there are any potential direct identifiers, again, that follow a specific pattern in your data set. And lastly, we can have combining variables to creating non-disclosive categories, such as rural, urban, unemployed, employed, things like that, if needed. The intruder scenario. It's always important when teaching and when doing risk assessment for any data to have this disclosure scenario in your head. Imagine yourself as an intruder. Who would be accessing the data? What would they be able to get from that data? And why would they do it? Now, when it comes to intruder scenarios, sometimes it's really good to take them to the extreme. My neighbor annoyed me. I know he took part in the annual population survey. I'm going to try to find out something his wife doesn't know about him. Luckily enough, there's nothing to find out because that data is extremely well anonymized. But potentially, what are the needs of secondary users? And this is why it's extremely important to have an open communication with the data producer when it comes to how you see that data being anonymized, or with them when they conduct the assessment and when they start applying different methods, because they are the ones to know what secondary users will want to do with that data, what do they want to analyze. And again, there's no point in sharing data that is basically unusable just for the, oh, I've shared my data, is available, but no one can make any use of it. Before doing any type of proper statistical disclosure control, it's very important to look at the key characteristics of the data. Do you have the population or do you have a sample? What do you know about the sample? Here, especially we're talking about cohort studies. Cohort studies can be quite difficult when it comes to disclosure control, because usually they're either born in a specific week or born in a specific week and place. So there already some pre-existing knowledge about the people you're looking in the data, even if it's not in there. So their exact date of birth is not in there, but we know they were born in the 12th week of 1998. What's the geographical coverage? Easiest way to ensure that the disclosure risk is minimized is when it comes to geographical coverage. While the data producer has the postcodes, has latitude and longitude, for example, if you want to make that data as available as possible, and probably I'm talking here about end user license, it would be good to aggregate it to a bigger category. So not making available postcodes or latitude and longitude especially, but making available something like government office region. And again, depending on your sample, you could even look at lower level geographies and how potentially you could make that available outside of a secure lab environment, of a safe haven environment. So for example, in the UK, local authorities are widely used. They are considerably smaller than government office regions, but they're widely used in analysis. So one way to go and be able to share that data as openly as possible is actually adding an extra layer on the end user license that users are signing for, and requiring project approval in depositor permission, so data owner permission, for them to access that data. They actually need to complete why they need that data. So not everyone can take it. They need to give proper information about the research and actually seeing that that data is needed. Very rarely applications are denied. Most of the times they are accepted because the people applying know what they want to do, and they do need that specific lower level geography for their own research. If they want postcodes, that is going to be via a safe room rather than a just depository permission only. Very important to bear in mind as well is the level of non-response in a key variable. If you're using an indirect identifier that has a very high level of non-response, if you're using it in any tool, when you're setting up your problem, is going to increase the level of global risk in your data set, because of course you'll have less combination from each as you have more non-responses in that specific variable. From a workflow perspective, it's quite important to present to anyone. You just don't get thrown in real life, not in exercise type scenarios, but in real life. You first explore and understand the data, read some documentation, understand more about the sample, geographical coverage, who conducted, why did they conduct it. You identify and delete all the direct identifiers, again, by discussing with the data owner, oh, you've left in names or contact addresses. Difficult part, identify the key variables. Calculating global risk, you'll see, is very easy in SDC Micro. You press a button and then it shows it to you. But identifying all the key variables can be quite time consuming, especially when we're talking about data sets with thousands of variables, because they can be very different key variables in there. Important thing here is you can run as many statistical disclosure control problems as you want. So you don't only test for one, you can test for different combination and different patterns in your data. And the rule is never to add more than 9 key identifiers, ideally no more than 6 key identifiers. The more key identifiers you have in your SDC problem, the higher the risk will be, because again, it's about the different combinations. So it's going to increase, potentially increasing with no real sense. But again, you can assess that by looking at the individual risk. Once we looked at both the global and the individual risk, we can apply appropriate techniques, banding, recoding, things like that, and recalculate the risk. Every single time you apply a method, you recalculate the risk, because you want to see, was this worth it? Or did I actually end up not doing too much in my data and it's all for nothing? Data environment. So I said at the beginning, we're going to briefly touch on functional anonymization. Functional anonymization is all about the data environment. So potentially you can consider a highly sensitive, containing very low-level geographies data set as functionally anonymized, as long as you take into control the data environment. So who's going to access that data? What other data exists in that data environment? What is the governance of that specific data set? And what is the infrastructure you make the data available under? So again, going back to the safe haven and controlled access assets, in a safe haven, there is no other data in the environment unless that specific user wants to link a data set with another data set, but that will be approved by the data owner, so they can't just do that. That needs to be approved. Not everyone can access that data. So depending from one organization to another, safe havens can have different requirements for data users. If it is an institutional safe haven, they usually require a bespoke data sharing agreement between the user and the data owner. If it is something similarly run as the UK Data Service, it actually requires users to either be accredited researchers under the UKSA scheme, the UK Statistics Authority scheme, or the ESRC pathway. They can become accredited researchers as well. The governance process is they can be accredited and trained, but if they're not actually vetted by the project, by the data owner, and their project is vetted as well, they have to complete quite a long form on why do they need that data, are they going to combine it with other data, why are they doing this research. That is actually checked by data access committees from the data owners, and only once they agree with them, data can be made available to them. Infrastructure data is only going to be made available to them remoting into a safe haven. So we're quite lucky at UKDS. We actually offer remote access. People don't need to travel to a physical safe room. There are other repositories that offer safe rooms. We have only one study that is restricted to safe room only and is not available for remote in. But again, remoting in, they won't be able to download the data. They can't take it outside of the controlled environment. They just need to remote into their machine and access the secure lab and follow all the strict procedures there. As an example, if you write something down on a piece of paper, that's a procedural breach, and they would end up with having their account suspended. So there are a lot of things put in place, from who's accessing the data, how are they accessing the data, what does the data owner need to do. It's a whole setup, but it's extremely useful when wanting to share potentially personal data or extremely sensitive data. When it comes to tools, it's very important to mention that they're fantastic for providing this comparison, because you can do it all manually. You can have a look at the data set, and the more you do this, the more you get in a sense of, oh, that age needs to be banded, oh, I need to top code the income, etc., etc. But if you do this manually, you don't have a reference value of saying, oh, what I've done actually changed the disclosure risk, lowered the disclosure risk, okay, or what I've done didn't have that much impact. They are quick and easy compared to doing, well, potentially you can do it manually and calculate using a formula and everything, but probably that would take ages. Tools are very quick and easy to explore. However, they are problematic when defining absolute risk. And it's really important whenever you teach on this to try to make it quite a big argument. It's not, if you don't use, for example, and you'll see with SDC Micro, and it's for all the tools out there, it's not just an SDC Micro problem. If you don't have a sampling weight, the tools will understand that's your population that you're giving it. The data that you're putting in is the entire population. So the risk will be extremely high, even though you don't have anything problematic in the data, or you might have a couple of variables each and there. So it's really important to put that out there as a caution when I train curators or researchers. I actually have a PNG with caution, which is orange, to make sure that's something they remember. Also, tools, they are time consuming and skill intensive to learn. Once you know them, they're quick and easy. But to actually learn to use them and use them properly, they are time intensive. There's a lot of documentation. There are a lot of new and fantastic enhancements being done. And they take a lot of time to get up to date. And there's no, it's continuous. It keeps changing, especially as the legislation changes. So it's always keeping up to date with the new legislation, the new criteria. Tool-wise, there are different types of tools. So we think QAMyData, we can use it for direct identifiers. Doesn't do anything in regards to calculating global risk, because there are other tools that do that out there already. But we do have Argos, that is a standalone software recommended by Eurostat for government statisticians. It's all free to download. It has quite a nice software manual. It's relatively easy to use. ARCS is a bit newer than Argos. But again, it's open source software with software and documentation available online on the web, no license needed. There's also a new tool developed by OpenAir, which is called the Media. That has been undergoing for quite some time, and they kept enhancing it. It looks fantastic now on the web. I haven't tested it in a lot of depth, but it looks amazing. So that's another potential tool that you could be using. Now, why did we choose SDC Micro? It is free. Oh, pardon me, I clicked when I shouldn't have clicked. It is free and it is R-based. In social sciences, we see a move towards R and using R packages quite a lot compared to other domains. So we think it fits the target audience, the bigger target audience. It does allow for calculating multiple statistical disclosure control methods. So you can apply perturbative and non-perturbative methods. As I said, it even does tram and adding noise and all of that, but I would be very careful with that. It allows you to calculate both the individual and the global risk. So what is the global risk, the entire data set, but then I can actually have a look at the different observations and be like, oh, you know what, this is actually not a problem in real life. So it calculated the risk based on what it knows, but it's not a problem. It does have a locally run graphical user interface. And while it's based on R, and R is fantastic, not everyone knows how to code in R. Having the graphical user interface allows anyone, no matter if they know R or not, to actually be able to use the tool. You just need to write 3 lines of code, basically installing the packages, calling the library, and the command to actually call the graphical user interface. What I usually do, and I've done in this case as well, when I share the materials with everyone, I upload the script to install SDC Micro, to call the library, and to also call the graphical user interface as a specific R script. People can use that. It's also documented in exercises everywhere, and of course, you're there to help them. Very important is to ask people to have R and RStudio installed, because they can take some time to install. SDC Micro is fantastic from a reproducibility perspective. We're going to see in the demo after the break, you can actually get out a proper R script that documents all the steps that you've done in the data. So again, SDC Micro doesn't override the data. You can save the data as and keep a copy, still have the original data, but you can, with that script, you can pass it to a colleague to see if they think it's okay. You can pass it to a data producer if you come from a data repository perspective. It's quite a useful feature SDC Micro allows, and also it provides reports as well. We're going to see in a minute what the reports are. They're fantastic for internal purposes, but I wouldn't necessarily send that to someone that doesn't know a lot about disclosure control, because they might say, for example, 5% disclose, 5% global risk, which might make some people panic, when in reality it's not 5%, it's actually a lot lower. And when looking at the individual disclosure risk, you will see that. But it's quite important to bear that in mind. The reports they look fantastic. They're done automatically. You don't need to do anything. But ideally, don't circulate it as widely. It is fantastically well documented. And while preparing the presentations for today, there is yet another new guide about SDC Micro, which was published on the 15th of July. 2021, so just a month ago. It's very detailed, fantastically nicely made with screenshots and everything. And I'll be sure to share that with you, because it can be used in training and while you learn to use the tools as well. When it comes to exercises, again, it does depend on the audience, how many exercises you include, but try to have as many around key concepts, direct versus indirect variables, variables from an SDC perspective. What would you like to include? What would you not like to include? Again, when it comes to different hands-on exercises, try to have a smallish data set. I do like to include quite a lot of buffer variables in, to give people that time to, oh, no, this is non-identifying, I can leave that. To give people the time to actually look throughout the variables, because if you only put the key variables in, then they're not going to gain anything out of that. Try to manually identify cases with higher disclosure. It's always worth trying to ask them. We can see people doing quite interesting things, trying to identify what would be the highest disclosure on an individual basis. Rarely the same as SDC Micro points out, but it's always worth if you have the time. So if you do an introductory session, a whole day, 8 hours, you can certainly have something like that. And then, of course, use a tool to identify the observation with the highest re-identification with a given set of predefined key variables. Ask them to find another disclosure control problem to set up other key variables that could be tested for. It's always good in our domain to know that, oh, I'm going to use the command SDC app from my library SDC Micro. If I run my SDC app, and now I need to change the screen because you're still seeing my R and you're not seeing my Google Chrome where it popped up. This is the graphical user interface of SDC Micro. it opens in your default browser. And ideally, you want your default browser to be set up as Chrome or Firefox or Opera, something that's more modern, is faster, and it ensures that it actually runs as it should. The graphical user interface itself is really well documented. You can actually see all the information on different websites they provide. The GitHub page is the CRAN website. As I've said, there's also a very nice user guide. It's not done by either of the package developers. It's done by someone else, but it's available online. July 15th of July 2021. It's very new and very in-depth as well. Now, when you're working with exercising, setting the storage path is not a problem. You can leave it to your documents because you're not saving anything that could potentially be confidential or include any privacy concerns. But if you are actually using it for a data set that you think is problematic, do change your storage path to a place that is safe on your machine or institutional machine. While it opens in the internet browser, the data is not going anywhere. It's a locally run interface. So it's not like we're putting the data up in the cloud or anywhere. It stays with us. It's on our local machine. If we go into the microdata tab, we can see there's several data types that SDC Micro accepts, including SPSS and STATA, the most widely used ones. It does have by default 2 test data sets in, however, they're not that well documented. I have seen recently, however, on the GitHub page, they are going to upload a new test data as well, which can be used. In my case, I'm going to use a very short SPSS file. And once we load in the microdata, again, we can inspect all the variables in here and make sure we understand what we're looking at. Ideally, before going into SDC Micro, we already looked at the data set, read any documentation, understand the concept of the data set. And once we have all of that in place, we go into SDC Micro. We can explore certain variables if we want, one by one. In here, we can see the different categories for each variable, the percentages, the frequencies, etc. We can already see ethnicity is a problematic variable in here, and ethnicity is actually one of the key variables when it comes to statistical disclosure control. It's usually either very detailed or extremely detailed. So there are cases where it is properly coded to not be that disclosive. One important thing to bear in mind with SDC Micro, it runs on R, so it uses R terminology, factors, categorical variables, and we have numerics, which can be continuous variables. It's very important when checking the variables, for example, if ethnicity by accident would have been converted to numeric, we can actually convert the variable either from factor to numeric or from numeric to factor. So it's important to know, we're going to see when we set up the SDC problem, we're going to specify, is this a categorical or is this a continuous variable? Also very important, all of this is documented in the PDF on the Google Drive in the exercises folder. If you have -8, -9, any missing values that SPSS data would understand very easily, is very important in SDC Micro to set them as NAs, because that's how R understands this is a missing value. By setting it to NA. It's very easy to set them to NAs. I'm going to just demonstrate that's not going, yes, it's not going to be an NA in real life, but I'm not using the is your fridge working variable in my statistical disclosure control problem, but you can just set them very easily and we can see all the yes turn to NA. Very important, if you do something that you're not meant to do, you can undo the last step. So if you go onto the undo tab, you can undo once you have an SDC problem, but you can always undo just one final step, so you can't undo more. If you change anything in here before setting up your SDC problem that you shouldn't have changed, you can always reset input data. Yes, I'm deleting my current input data. It's gone, and I can import it again. Again, there are no changes done on the data. The data that is going to bring in is the one that I want to use with, is your fridge working correctly? Yes and no. Now, when it comes to anonymizing, in the anonymizing tab just at the top, you can actually set all your key variables you want to include in your problem. As I said, ideally you don't want more than 6 in each problem, because then it becomes a problematic problem. Sometimes making the disclosure is much higher than it is because we're including too many variables. Now, there are certain variables which are always considered key variables. We have 6. Age, which is a continuous variable, is not a categorical one. Ethnicity, which is a categorical. Religion is a categorical. Highest qualification. So again, I'm thinking, what are the variables that could potentially identify an individual when put together? This is how I explain it to everyone while doing this thing. Look at the variables and be like, oh, occupation, yes, most certainly. Now, cancer, and cancer is a dummy variable in our case. It's a yes or a no. And I've included it in here. When I'm discussing ill diversity, I am not including ill diversity anymore to all audiences. Ill diversity is a continuation of k-anonymity, but it's for sensitive variables, so it checks how many observations within a group have a specific category for my ill diversity variable. So for example, if I have 5 females with a bachelor's degree that are bakers, and all of them have cancer, that's problematic because it doesn't give that variability. If you know one that participated in that survey, you will know she has cancer because all of them have. But having yes and no, and you have, for example, 4 that tick yes and 1 that ticks no, then that would give that variability of, oh, I'm not actually sure, they could have cancer or they could not have cancer, because it's not that clear. However, I do not include ill diversity in all the training that I do on statistical disclosure control. If people ask questions about sensitive variables, can we check for that? Yes, but usually this is extremely useful from a health perspective, especially ill diversity can be used fantastically well when it comes to that. For this, we don't need to add it to our statistical disclosure control problem. It's very important to add our government office region core here. That's government office region, our geographical coverage. And we also have the weighting variable called just weight, and we need to tick the weighting box. So we select all the categorical ones by ticking the box. The continuous one, we only have age in our case, and the weight, we need to tick the appropriate box. Now we can set up our SDC problem. This runs as fast as your computer is, and depending on how big the data set is. So if you're working with a very large data set, running could take a bit longer, but it usually is in the blink of an eye. As you've seen, it does it very fast. The very first screen, it actually provides the summary of what you've selected, making sure that this is what you wanted to see. So the categorical key variables are sex, ethnicity, religion, highest qualification, occupation, and government office region. And we have a numerical key continuous variable, age, and also my sampling weight in the data file is weight. We can see basic information on categorical key variables here. What is the frequency of smallest level, the average frequency, and the number of levels. And we can also see the information on k-anonymity. So the k-anonymity is a very basic concept, but again, it depends who you're teaching this to. K-anonymity is extremely used for when one wants to publish open license data as open as possible. We'll see in a minute, you can press a button and it anonymizes your data. What that does, by selecting the variables that you want, it ensures that depending on the K anonymity level you select, for example, if we select 5, that no combination of your key variables are less than 5. So we have at least 5. If we look on the variables we selected, female, Black, Buddhist, bachelor with a bachelor degree, that are bakers in North Yorkshire. You will always have 5 of these categories. So it sets them for all the categories on your key variables. You won't have just 1 or 2 observations like that. It's very, again, widely used when it comes to publishing open license data, but it can be problematic when thinking from a usability perspective, because by just pressing that button, you might end up suppressing quite a lot of information in your data. So that's why I'm saying a lot of reading is nothing that can be taught or learned in a day or half a day. There's a lot of trial and error, I would say, trying with different data sets, identifying different problems in different categories. Now, the first step you do, once you've seen the summary, you're fine, you've selected everything that you wanted to actually select, is to actually check the risk and utility information. In here, you can see the global risk, and we can see that we expect 44.14 re-identification in my data set, giving me a 1.19 global risk of disclosure. Again, the 44.14 re-identifications are based on the mathematical formula behind calculating global risk, which assumes my weighting sample is correct, and that's all the information I know about that specific individual, so I can certainly identify that person. That's when we take the defining the absolute risk with, oh, is that really the case? And we go into our risky observations, and here we can see what the individual risk is, depending on the different categorical key variables that we've set. Again, this is not going to show all the variables that you have in the data set, just the one that you set as your key variables. We can sort out by the individual risk from higher to lower, and we can see the highest individual risk is 0.046, which again is actually very, very low. And we have someone that it's a male, of Black African ethnicity, Christianity as religion. Oh, I'm sorry, I scrolled when I shouldn't. We have a postgraduate, it's a cook, and it lives in London. Now, very important, the FK and the uppercase FK, that is the sample observation, the lower one. So in my sample, in my data, I have just one person that fits this criteria here. However, in the population, I have 101 people that fit this criteria. So now experience comes in, and if I have 101, do I actually need to treat this, or is nothing that would potentially cause any problem? And there's nothing that would potentially cause any problems. You can reduce the risk lower, but this data would be fine to be published under an end user license, making sure that people understand data confidentiality. They're not going to share the data with whomever, but you're fine to publish it like that. However, CESSDA Micro gives you the option. Oh, I apologize. I've changed the tab instead of changing the risk measures. It gives you the option, which again, I find fantastic from a usability perspective, of calculating the SUDA2 risk measure, which is basically giving you what variable is more problematic in the key variables you've identified. And we can see, as discussed in the presentation, the geographical variable, the government office region is the one that's most problematic. However, we are using in this case a very high level geographical we do have a question. How does it know how many cases there are in the population? That is based on the sampling weighting we have added in. So when we go back to anonymized, we've used the weight variable, which is basically derived from the census. Well, it's derived from my head because this is a pure teaching data set, demo data set. It's not the real weighting variable.
This video is produced by the Consortium of European Social Science Data Archives. For more information on CESSDA, please visit www.cessda.eu.